So I've started two pendulums in motion and I dropped them from different amplitudes. The one on the left I dropped from 30 degrees, the one on the right I dropped with an amplitude of 10 degrees. And you'll see that the time in which it takes for them to complete the period is the same, but the difference is their amplitude. And I've graphed it behind here. So let's talk about what it means for them to be in phase. They are in phase. The only difference is their amplitude. So I've labeled this graph over here. My y-axis, my vertical axis, is the amplitude. And my x-axis, I've simply just graphed each of them to travel through one oscillation. So the 30-degree amplitude, it just travels further from the equilibrium point. Whereas the 20-degree graph, you'll see, travels a little bit closer to equilibrium, and the 10-degree has a much smaller amplitude. And what we're able to compare here is that the amplitudes change, but the amplitude does not affect the period of the pendulum. When we talk about in phase, we're really talking about the two that are oscillating are just synchronized. They are in harmony with one another. So how and why does that happen? Well, here's how. That a pendulum that's dropped from a greater speed, at a greater amplitude, say 30-degree, greater amplitude of 30 degrees, it's actually going to travel faster over this distance, right? It's going to cover a greater area. It's going to travel faster to make up for it. So it's traveling faster to get from here over and back, whereas my amplitude of 10 degrees, it doesn't have as far to travel, so it's going to travel proportionally slower. So it's going to travel over and back. So you can actually talk or look at the rate at which these pendulums oscillate and see that the amplitude does not affect the period, because of greater amplitude simply going to travel faster to cover the greater distance, and a smaller amplitude is going to travel at a slower speed.